Hello everyone. Today we're going to learn about how to write the names and formulas for ionic compounds. A quick review of what an ionic compound is. An ionic compound is one in which ionic bonds are present. Ionic bonds form when a cation is attracted to an anion. Traditionally, ionic bonds are thought of as the transfer of electrons being involved. And during this transfer, the atom that will become the cation gives its electrons away to the other atom, which will become the anion. So, what kind of elements generally participate in ionic bonding? Ionic bonds require a cation and an anion to form, which means in order to make a cation, we need an element that has low ionization energy and also low electronegativity, so that it's easy to pull that electron away from it, and it also is not very good at grabbing electrons. Therefore, a cation is probably going to be a metal. They are known for having low ionization energy and low electronegativity. An anion, on the other hand, is going to have high ionization energy and high electronegativity. It needs to not be easy to remove an electron from it so that it won't become the cation, and it needs the ability to pull electrons towards itself very well. Therefore, the anion is likely to be a nonmetal. There are, of course, some exceptions to both these rules, those exceptions being the polyatomic ions. Polyatomic ions are a collection of atoms held together by covalent bonds. Most of the polyatomic ions involve nonmetals, although there are a few, such as the permanganate ion, that involve metals as well. Some examples of possible polyatomic ions that you might see include the ammonium cation, the sulfate anion, and the phosphate anion, to name just a few. There are many polyatomic ions, so keep an eye out for them. Let's first look at how to write the formulas for ionic compounds, because there is a skill here that we will need in order to be able to write the names of a few select compounds. Ionic compounds are electrically neutral, as is all other compounds. The charges from the cations and anions are going to have to equal each other out, just in the same way that the protons and electrons of an atom must balance out to make the atom itself neutral. So, when you write the formula of an ionic compound, there's a lot of math, if you will, involved with the charges in order to find the correct balance. So let's look at an example. Example, write the formula for the compound formed when the aluminum cation and the chloride anion form a compound. First, we should consider a common multiple between the charges, which are 3 and 1. The common multiple of 3 and 1 is 3, conveniently, which means that the total charge from the cations must equal 3, and the total charge from the anions must equal -3 in order for there to be creating a balance. So let us consider, how many aluminum ions would I need in order to get a total positive charge of +3 in the compound? I would only need one. Aluminum already has that +3 charge, so aluminum will have only one, which, since we'd be writing it as a subscript, we do not need to include it. How many chloride ions am I going to need in order to get to a total charge of -3? Since each chloride ion has a charge of -1, I will need a total of 3 of them. Therefore, the subscript for the chlorine will be 3, because I will need 3 ions. So, the formula for the compound formed between the aluminum cation and chloride anion will be AlCl3. You'll notice the 1 for the aluminum has been left off because it does not need to be explicitly stated. Let's try another one. Write the formula for calcium nitride. This is an ionic compound, and we must try to write its name. First, we need the common charges of the elements involved. Calcium is an alkaline earth metal, and therefore its common charge is +2. Nitrogen is the element that nitride is talking about, and nitrogen's common charge is -3. So now that we have our charges, we can look for the common multiple. What is the common multiple of 2 and 3? The common multiple of 2 and 3 is 6. So we'll need total charges of +6 and -6 in order to create a balance in the formula. So how many calcium ions are we going to need in order to get a total charge of +6? Since each calcium has a +2 charge, I will need 3 total calciums. So the first part of our formula will be Ca3. Next, how many nitride ions are we going to need in order to form a charge of -6? Since each nitride bears a charge of -3, I will need 2 of them in order to get to -6. So the second half of the formula will be N2. We string our two pieces together and get that the formula of calcium nitride is Ca3N2. This is how we write formulas for compounds. A quick tip to help you figure out quickly what the superscripts will be. Because what generally happens to find the common multiple is that you simply multiply the two charges, that means that generally if you simply swap their places, you will get to the correct answer that you need. This is represented by the arrows here on the screen, with the red arrow dragging the 3 down from its charge as nitrogen to be the subscript for calcium, and the blue arrow dragging down the +2 from calcium to make it the subscript of nitrogen. This is a quick way to get the subscripts. Please note, if you do this, you will have to double check if you need to reduce anything. For example, if you had 2 and 4, you could reduce those to 1 and 2. Ionic compounds are electrically neutral, as a reminder. So let's talk a little bit about how we name them. Because, as we saw previously, there's only really one possible combination for when you combine the ions. That means I don't need to have a numeric prefix in the name like I would for a covalent compound. Covalent compounds have multiple possible ratios, but ionic compounds only have one. So there are no prefixes here. So let's do some quick examples, since they will be a little more straightforward. Let's write the names for the following compounds: NaCl, MgF2, NaNO3, and NH4Br. Our first formula, NaCl, contains the sodium and the chlorine atoms. You might remember that the second element gets an IDE ending, and so the name for this formula is simply sodium chloride. Notice there is no prefix that indicates number. The number is assumed because the common charge of sodium is +1 and the common charge of chlorine is -1. For MgF2, the two elements talked about are magnesium and fluorine, so I change fluorine's ending to fluoride, and I get magnesium fluoride as the name for MgF2. Our next formula is a little trickier. You'll notice there are 3 elements present, which indicates there is a polyatomic ion present in NaNO3. In the formula NaNO3, there is the sodium cation out in front, and then NO3 is the nitrate ion, one of the polyatomic ions. The polyatomic ions already have appropriate endings on them, and so you do not need to change them. The name of this would simply be sodium nitrate. Our next formula also involves a polyatomic ion. Look carefully and determine what is the polyatomic ion involved in NH4Br. NH4Br contains the ammonium cation, one of the few polyatomic cations we will encounter in this course, and bromine. We will need to change bromine's ending to make it bromide, but then the name for NH4Br would be ammonium bromide. There is only one additional thing that might show up in the name of an ionic compound, and it only shows up if a transition metal is involved. This is because if we consider elements like sodium, calcium, or nitrogen, like we saw in the previous slides, have predictable common charges that can be predicted on the periodic table. And so, if I see their name, I assume their charge. However, transition metals have multiple common charges due to the fact that they have d electrons, which creates an unusual set of valence electrons. So metals like chromium, nickel, or copper have multiple possible charges. I would need to indicate which of its charges is being involved in order to determine what ratio is present for that compound. In order to indicate the charge for the metal involved, we will be using Roman numerals in parentheses following the name of the metal. For those of you who do not know your Roman numerals, the table below gives you a list of the common Roman numerals you might find. Generally speaking, we won't go beyond 5, but just in case, I've also listed +6 and +7 here, just in case you might need them at some point. So, let us look at how to write the name of a compound formed from chromium 3+ and sulfate. Chromium is a transition metal. and so we will have to indicate its charge in the name. The charge here is +3, so we'll use the Roman numeral 3, which is 3 i's in a row. SO4 with a -2 charge is the sulfate ion, one of our polyatomic ions. And so when we write the name, we will say chromium 3, indicating that the 3 is the charge of the chromium, and then sulfate. So the name is chromium 3 sulfate. Let us look at a second example. Write the name for the compound V2O5. The elements involved here are vanadium and oxygen. Oxygen has a common charge of -2, and it is fine, so we don't need a Roman numeral there. Vanadium, however, is a transition metal, and therefore can have multiple charges. Vanadium can have a couple of different ones, so let's figure out what it is. But how am I going to figure out what it is? Well, there are a couple different methods that you can do that involve the common multiple thing that we saw earlier when we learned how to write the formula. The easiest way is to consider that trick with the arrows that I showed previously and simply undo it. So you'll notice the red arrow for the top image is dragging the 2 next to vanadium up to the top of oxygen to indicate that its charge was originally -2, which is the charge for oxygen. So that checks out. If we do the same to the 5 next to oxygen and place it as the charge for vanadium, we discover that vanadium's charge here is +5. So when we name this, that is the vanadium 5 cation. Therefore, the name for V2O5 is vanadium 5 oxide. Now that you know how to write the names and formulas of ionic compounds, go forth and practice. Good luck!